Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 1 Measurement and Experimentation. We will be discussing the topic Measurement of Time and Simple Pendulum. Hope you all are ready for the session. Let's begin. First topic to discuss is simple pendulum. What is a simple pendulum? In case of a simple pendulum, you will be having a rigid support using a string, a mass, any mass, a ball will be suspended. Okay, this mass which is suspended is called a bob. Okay, so this bob's three position we have to note: O, A and B. O is the rest position or the main position. From there, when you pull this bob, what happens? It gets displaced from this position, it comes to the position A. Okay, once it reaches A and when I am releasing it, what happens? It will go to O and through O it will go to a new position B. Okay. These A and B positions are called extreme position. Here the ball is called a bob and this bob is of a mass M. The string that is considered will be of a negligible mass. Okay, here what is happening? The ball is getting displaced when it is released. Okay, so from here it will start, move to this end, then move to this end. This will happen continuously and finally it will be coming to rest. So during this we call it as oscillation. The bob is said to be oscillating. So here this is the basic idea about a simple pendulum. The normal pendulum clocks are made up of compound pendulum which we will be discussing. So in case of a pendulum clock, I am sure that all of you have seen a pendulum clock. It can be in your house or office, you will be having in the schools, you will be having this pendulum clock. Okay, in case of pendulum clock, you can see that this is a horizontal line and the oscillation, this bob is oscillating along the horizontal axis. Okay, so this is not a simple pendulum and the pendulum used here is a compound pendulum. A pendulum that is capable of oscillating along a horizontal axis is called a compound pendulum. When you study about simple pendulum, there are 5 important terms that we need to know that we will be using in any problems that is related to simple pendulum. First one is oscillation. One complete to and fro motion of the bob of a pendulum is called oscillation. We have said about oscillation. When this bob is displaced, what happens? It will be moving to this end, then to this end, that is O to A to O, O to B, B to O, O to A. This is happening continuously. One complete to and fro motion is called an oscillation. If the bob is starting from O, it will move from O to A, then A to B and back to O. Okay, this makes a complete oscillation. Either you can say like this, or a bob that is starting, that is when you displace a bob from A, you release it from A. What happens? It goes from A to B, then from B to A. This makes a complete oscillation. This is an oscillation. Okay, either you can say O to A to B, B to O, or A to B, then back from B to A. This is a complete oscillation. Got it? Now the second one, period of oscillation or time period. This is a time taken to complete one oscillation. We understood what is one oscillation? To move from A to B and back from B to A. What is the time taken? This time taken is called time period, which is represented by the letter capital T and its unit will be seconds. Okay, it is a time, therefore the unit should be seconds. Next is frequency. It is the number of oscillation made in 1 second. Okay, here in 1 second, as we said, there is a time for oscillation. For one complete oscillation, we said T seconds. Okay, so for 1 second, how many oscillations is called the frequency, which is represented by F or represented by N. The unit is hertz, which we represent it by Hz or it is second inverse. Okay, there is a relation between time period and frequency. We said that in time T seconds, one oscillation. Okay, one oscillation in T seconds. So in 1 second, how many oscillations you will have? 1 by T oscillations. Okay, 1 by T oscillation. That is the number of oscillations in 1 second is called frequency. Therefore, frequency will be equal to 1 by time period. This is a relation, or time period is equal to 1 by frequency. Okay, as we said, the unit of time period is second. Therefore, what will be the unit of frequency? Second inverse. 1 by second, which is second inverse. So, this is a third term, frequency. Next is amplitude, the maximum displacement of the bob from its mean position on either side. Okay, here you can see O is the mean position or rest position. From this rest position, it is taken to A and B, right? So, when you take it to A, this is a maximum displacement that we can bring. Okay, maximum distance that can be moved. The bob can move from its mean position is called the amplitude. Okay, here this is the amplitude. Maximum displacement is called. That's the maximum displacement from its mean position. Here this is A and B are the extreme positions. Okay, so this displacement is called amplitude, which is represented by capital letter A, and the unit, it is a length, therefore the unit will be meters. Next, effective length of a pendulum. It is the distance of the point of oscillation from the point of suspension. Point of suspension, this is the suspension point. Point of oscillation, so here we have the point of oscillation. That is, this length of the string is the effective length. Okay, got it? This is the effective length of the pendulum, which we represented by letter L, and the unit will be meters. L meters. Clear? So, these are the 5 important terms that you need to know. Measurement of time period of a simple pendulum. How to measure time period of a simple pendulum? Here we have collected data by performing an experiment using the simple pendulum. A simple pendulum setup, we know there will be a rigid support, inextensible string and a bob. The bob will be displaced. In this experiment, what we are going to do is we have taken 6 times the experiment is performed and the values are taken. Okay, we are changing the length of the string, that is 25, 36, 49, 64, 81 and 100 are the different lengths that we are taking. For these different lengths, we will be finding the time period. Okay, then during this experiment, we are taking the time for 20 oscillation. You need a stopwatch, and you will be, that is when the bob is displaced, you will be first having the bob at its mean position to its extreme end we are taken, that is position A. From there it is released, it will go to B, come back to A. Completes a oscillation. Again to B, back to A. 2 oscillations. So, like that we will be counting for 20 oscillations. What is the time taken? We will be setting the timer. In the stopwatch, we will be getting the value. Okay, this value will be noted. So, this value 20 is the time taken for 20 oscillation when the length of string is 25. Then we will be changing the length of string to 36 and performing the same experiment. We will be finding the time taken for 20 oscillation. You will be getting 24, 49, 28. When the string is of length 64, then 32, 81, 36 and 140. Okay, we got the time for 20 oscillation. How to calculate time period? Time period is the total time taken divided by number of oscillation. Here the number of oscillations is 20. Okay, therefore time period T will be equal to T divided by 20. When you find this, you will be getting 1, 1.2, 1.4, 1.6, 1.8 and 2. Okay, so this is the time period. Next, we will be finding L by T square. Okay, we will understand why we need to find this. L by T square. So, these are the time period values. So, T square, 1 square will be 1, 1.2 square, 1.44. So, like that you will be finding T square values and divide this T square value by the length L. Okay, then you will be getting the same value, which means this L by T square that we are getting will be a constant. Here we are getting 25. Clear? Now we are going to plot a graph with T square versus L, where L is the effective length and T square, the time period square. Okay, here we are going to take along the x-axis. Along the x-axis we will be taking the length, and along the y-axis we will be taking square of the time period, T square. Okay, so here we have L values 25, 36, 49, 64, 81, 100. Put the values 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. Now, T square values. Here we know the time period. I have taken the square of it. So, 1, 1.44, 1.96, 2.56, 3.24, 4.0. These values, for that I will be taking 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. Okay. Now we can plot the graph. First, when the length is 25, we are getting time period square 1. Okay, for 25, here we have 25, it is 1. Next, when the length is 36, we are getting 1.44. Where do we have 36? Here we have 36, 1.44. So this is 1, 1.2, 1.3, 1.4. Here you will be getting it. So this is the point. Next, 49, 1.96. Where do we have 49? This is 49, 1.96. 1.96 will be approximately close to 2. Somewhere here. Okay. Next, 64, 2.56. 64, 2.56. So here we will be having 2.56. Next, 81, 3.24. 81, here we have 81, 3.24. Somewhere here you will be getting. Okay. Next, 100, it is 4. Here we have 100, this is 4. When you join these points, okay, I am joining these points, I will be getting a straight line. Okay, you can see this is a straight line. So when you join these points, that is maximum points can be included in a straight line. So here you can see these points can be included. You will be getting a straight line that is inclined to the x-axis or the length axis. Okay, you can see this is inclined to the length axis. So what do you understand from this? When the t square versus L graph is drawn, you will be getting a straight line that is inclined to the length axis. We have said that L by t square value when taken, you are getting a constant. Okay, here this gives the L by t square values. When the t square versus L graph is plotted, this is how it looks like. You will be having a straight line that is inclined to the x-axis or the length axis. Okay, now we are going to find the slope. To get the slope, what you are going to do is you need to consider 2 points. Here we have taken 2 points P and Q along this line. Okay, from this point P, we are going to find the points where when a normal is drawn from P, it meets the y-axis and x-axis. Here at point A, the normal from P meets the y-axis and at C it meets the x-axis. Okay, here this is length. So this length we take as L1 and this square of time period we take as T1 square. Similarly for Q, you will be having T2 square and L2. Okay, now we are going to find the slope. Slope is equal to tan theta. Here for this right triangle, I am going to consider an angle theta. Okay. We will be discussing trigonometry in detail. Now just understand theta is some angle. Now this side is the opposite side and this side is the adjacent side for angle Q. Okay. So when you take tan theta, you will be getting the slope and the slope will be equal to opposite side divided by adjacent side, which is equal to PR divided by QR. Okay, what is PR? PR will be equal to T1 square minus T2 square. Till here the length is T1 square, till here it is T2 square. So we need to subtract this T2 square part from the whole T1 square part. Similarly, when you take QR, this total length is L1. To get this part, you need to subtract this part. Yes. So L1 minus L2. PR is T1 square minus T2 square divided by QR is L1 minus L2. So this is the slope. When you find the slope, you will be getting a constant value which is equal to 4 pi square divided by G. Okay. What is G? G is the acceleration due to gravity whose value is 9.8 meter per second square. So when you find the slope after plotting the graph, you will be getting a constant value because 4 is a constant, pi is a constant, therefore pi square will be a constant and G value of G is 9.8 meter per second square. So here we will be having slope is equal to 4 pi square divided by G, or you can say G is equal to 4 pi square divided by slope of t square versus L graph. Okay. G value you will be getting when you know the slope of t square versus L graph, and 4 pi square is a constant. Clear? Now what are the factors affecting the time period of a simple pendulum? First, one is the time period of an oscillation is directly proportional to the square root of its effective length. Effective length we are representing by letter L. So time period is directly proportional to root L, or t square is proportional to L, which we have got from the graph. We have taken the slope, right? So we have understood that length versus t square graph when we are drawing. When length increases, what is happening to t square? T square is also increasing, which means they are directly proportional, and the rate is t square proportional to L or t proportional to root L. Okay. Now from this you will understand that we know in case of a pendulum clock you are using compound pendulum, or when you take the case of simple pendulum as well, you can see that these pendulums are made up of brass or steel. Okay, the bob will be made up of these materials. So when temperature changes, there will be some changes, right, in natural changes. When temperature changes, for example, when you take the case of a winter season and summer season, in winter season temperature is less. Yes, during this what happens is the length of the pendulum gets shortened, that is length is decreasing. When length is decreasing, what happens to time period? Time period will also decrease. Okay, we have time period is equal to total time divided by number of oscillations. Okay, so when the time period is decreasing, what happens to the number of oscillations? Number of oscillations will increase. So during winter season, the length of pendulum will decrease. Therefore, time period will also decrease, because length of pendulum and time period are directly proportional by the rate t proportional to root L. Okay. When this time period decreases, number of oscillation increases. Why? Because time period and number of oscillations are inversely proportional. Now, what about the case of summer season? In summer, temperature is increasing. Temperature is increasing means the length of the pendulum will expand. Okay, length of the string will expand. When length increases, what happens? The time period also increases. When time period increases, number of oscillations will decrease. Clear? So this is how time period is dependent on the length, effective length of the pendulum. So with this example, we will understand in detail. When you consider a case, a boy is sitting on a swing and a girl is standing on a swing. Okay, in which case is the effective length more? Here the effective length will be more when the boy is sitting, right, compared to the girl. So here in this case we have length higher. So L1 is greater than L2. Okay, we are taking length of this string. When the boy is sitting, we will be taking it as L1 and this as this length as L2. Okay, L1 is greater than L2, which means T1 will be greater than T2. The time period will be greater in case of the boy. Okay, and what about the number of oscillations? Number of oscillations, if you are taking it as N, N1 will be less than N2, because time period and number of oscillations are inversely proportional. Okay, so this is how time period depends on the effective length. Second factor is the time period of a simple pendulum depends on the acceleration due to gravity. Let's see how. Time period will be inversely proportional to root of g. We got t proportional to root L and t is inversely proportional to root of acceleration due to gravity. So when you're taking the case, when you're going to a mountain, okay, when you go to a mountain, we are taking this pendulum clock to a mountain. There what happens is g value decreases. When g value decreases, what happens to time period? Time period will increase. Yes, time period of oscillation will increase, which means the pendulum clock is going to slow down, because the time taken, that is the time for oscillation, is time period for oscillation is increasing, and hence the pendulum clock will slow down at mountains. So this is the dependence of time period on acceleration due to gravity. Next is how time period is dependent on mass. Actually, time period does not depend on mass. If you are taking two pendulums, okay, you are suspending two pendulums. This is the first one and this is the second one. So here you can see this is of mass m1, this is of mass m2. m2 is greater than m1. Yes, mass of the second pendulum is greater than the mass of first pendulum. Still the time period is not going to change. If you are taking both the bobs, both the pendulums of effective length same effective length, then even if the mass changes, there is not going to be any change in the time period. So, time period is independent of the mass or the material that is being used. Material of the board does not make any change in the time period. Fourth one, the time period of oscillation does not depend on the extent of swing on either side. That is, when you take this, when you displace this bob from its mean position, what is happening? It is taken to an extreme end. Okay. So, when I pull this, I will be taking to one end. Okay. So, from there when released, it will be moving to the next extreme end. So, this is going to happen and we call this amplitude. That is, the maximum displacement is called amplitude. So, when this amplitude changes, there is not going to be any change in time period. So, time period is independent of amplitude. That is the maximum displacement. Okay, these are the 4 factors, of which on 2 factors the time period is dependent. They are length and acceleration due to gravity. The time period is independent of amplitude and the mass of the pendulum. Next, what is the expression for time period of a simple pendulum? We have got a relation G is equal to 4 pi square divided by slope of t square versus L graph. Okay. Also, we have said that time period is proportional to root L and time period is inversely proportional to root G. So, this can be written as T proportional to root of L divided by G. I am combining these 2 equations. Okay. So, T is directly proportional to root of L by G. To remove this proportionality, I am going to insert a constant. Okay. So, T is equal to 2 pi root of L by G. So, this is the relation. T is equal to 2 pi root of L by G, where pi is a constant, 2 is a constant. At a given place, G value is equal to 9.8 meter per second square. So, depending on length, when length changes, time period changes by this relation. Okay, here we got G is equal to 4 pi square divided by slope of t square versus L. So, this can be written as t square is equal to 4 pi square into L divided by G. I am squaring on both sides. Okay, or we can say G is equal to 4 pi square by t square into L, or this is 4 pi square divided by t square by L. So, what is t square by L? T square by L is the slope of t square versus L graph. Okay. Here we had t1 square minus t2 square and that is t square. L1 minus L2 is L. So, this is the relation. So, at a fixed place, at a position, if you are having a clock at a position, there the G value is not going to change. Yes, G value will be a constant and the length of pendulum will also be a constant. So, there you can use this pendulums to measure the time, and this is the reason why pendulums are used to measure time. Normally, the pendulum clock that we are using will have a seconds pendulum. So, what is a seconds pendulum? As the name suggests, a pendulum with time period equal to t is equal to 2 seconds is called a seconds pendulum. So, in case of a seconds pendulum, so for one motion, that is you start from O, move to A, extreme end A, back to O. Okay, the time taken here will be 1 second. So, from here again to B, back to O, 1 second. So, 1 plus 1, 2 seconds. So, this is the time for one complete oscillation starting from O to A, B to O. Okay. So, here it makes a complete oscillation and the time taken will be 2 seconds, 1 second plus 1 second. Or if you are starting from A, okay, extreme end A, you are releasing the bob, it goes to O, from there to this end B, okay. Back from B to A, the total time taken will be 2 seconds. From A to B, the time taken is 1 second. From B to A, the time taken is 1 second. So, this is what a second pendulum is. Here, the time period will be 2 seconds. So, for a normal pendulum that is considered when acceleration due to gravity G is equal to 9.8 meter per second square, you will be having the effective length L value to be equal to 1 meters. Okay, we have the relation T is equal to 2 pi root of L by G. So what is L from this? Here you have root L by G is equal to T by 2 pi. L is equal to G into T square by 4 pi square. Okay. We are taking the square on both sides and taking this G to the opposite side. Putting the values, G is equal to 9.8 meter per second square, time period 2 seconds, pi value is 3.14, approximately you will be getting the effective length to be equal to 1 meters. Okay, let us take an example. Example 1, calculate the length of a seconds pendulum at a place where G is equal to 9.8 meter per second square. So we know that time period T is equal to, time period of a simple pendulum T is equal to 2 pi root of L by G, where L is the length of the pendulum and G is acceleration due to gravity. Okay, we know the value of pi, which is 3.14. Now here what is given? It is given that we have to calculate the length of seconds pendulum. What is a seconds pendulum? A seconds pendulum is a pendulum whose time period is 2 seconds. Okay, therefore T is equal to 2 seconds. What else is given? Acceleration due to gravity G is equal to 9.8 meter per second square. Okay, from this how can we find L? From this equation, that is T is equal to 2 pi root of L by G, we will be having root L by G is equal to T divided by 2 pi. Yes. Now L by G, if you are squaring on both sides, then L by G will be equal to T by 2 pi whole square. Okay, and L will be equal to G T square divided by 4 pi square. 2 square is 4 and pi square. Now put the values. G is 9.8. G is 9.8 into T square, which is 2 square, divided by 4 into 3.14 whole square. Okay, so when you calculate this, you will be getting 0.994 meters. Since we are finding length, the unit should be meters. 0.994 meters is your final answer. So this is the length of a seconds pendulum. Clear? Second example, compare the time periods of a simple pendulum at places where G is 9.8 meter per second square and 4.36 meter per second square respectively. At two different places, the acceleration due to gravity is different and we have to find the time period ratio. Okay, so first when G is equal to 9.8 meter per second square, we know time period T is equal to 2 pi root of L by G. So first time period T1 we are calculating, T1 will be equal to 2 pi root of, given that we are to compare the time periods of a simple pendulum. Same simple pendulum we are using, therefore length of pendulum will be same, L divided by G1. Okay, here G1 is equal to 9.8 meter per second square. 2 pi root of L by 9.8. Okay, what about T2? T2 is equal to 2 pi root of L by G2, which is 2 pi root of L by G2 is 4.36. Okay, we need the ratio, that is T1 divided by T2 is equal to 2 pi root of L by 9.8 divided by 2 pi root of L divided by 4.36. Okay, 2 pi gets cancelled, root L gets cancelled, then you will be having root of 4.36, that is we are taking the reciprocal. Okay, 4.36 divided by 9.8. When you find the root of this, you will be getting the ratio to be 1 divided by 1.5. Okay, in ratio we need it as a whole numbers. So what you are going to do is you are multiplying numerator and denominator with 2. You will be getting 2 divided by 3. Therefore, T1 is to T2 is equal to, the ratio is 2 is to 3. Okay, so time periods of the ratio of the time periods of a simple pendulum at G is equal to 9.8 and 4.36 is equal to 2 is to 3. Third example, compare the time periods of two simple pendulums of length 1 meter and 16 meter at a place, at the same place. So therefore, the acceleration due to gravity will be the same. So we know that time period T is equal to 2 pi root of L by G. How is time period dependent on L? Here G is a constant, 2 and pi are also constants. So T is directly proportional to root of L, which means T1 proportional to root L1, T2 proportional to root L2. Okay, if you are taking it as like this, all other terms will get cancelled. 2 pi and root G will be cancelled when we take the ratio. So taking the ratio, T1 by T2 will be equal to root L1 by root L2 or root of L1 divided by L2, which is equal to root of L1 is 1 meter and L2 is 16 meter. Okay. So T1 by T2 is equal to root of 1 by 16. What is root 1? 1. Root 16 is 4. What is the ratio then? T1 is to T2 is equal to 1 is to 4. So 1 is to 4 is the ratio of time periods. Clear? Example 4. A simple pendulum is made by suspending a bob of mass 500 gram by a string of length 1 meter. Calculate its time period at a place where G is equal to 10 meter per second square. How to calculate time period? T is equal to 2 pi root of L by G. T is equal to 2 into 3.14 into root of 1 divided by 10. G is given to be equal to 10 meter per second square. So when you do the calculation, you will be getting 1.99 seconds. Okay, so this is the time period. Now, the second part of the question, B. How will the time period in part A be affected if the bob of mass 100 gram is used, keeping the length of string unchanged? Here you can see that time period is dependent on the length and the acceleration due to gravity, not on mass. If the size or the mass of the bob, you are changing the bob, there is going to be no change in time period. Time period will remain the same. Why? Because time period is independent of mass. Okay, so B part, time period remains unaffected because time period is independent of mass in case of a simple pendulum. Okay, so when mass changes, don't think that the time period is also going to change, because time period depends only on the length and acceleration due to gravity. Now let us solve questions from exercise 1C. Question 1 of exercise 1C. A simple pendulum completes 40 oscillations in 1 minute. Find its frequency and time period. So here it is given that in 1 minute 40 oscillation. What is frequency? Frequency is the number of oscillations in 1 second. So frequency is number of oscillations in 1 second. Okay, so it is given that in 1 minute 40 oscillations. Okay, 1 minute is equal to 60 seconds. So in 60 seconds we are having 40 oscillations. Then 1 second the number of oscillations will be 40 by 60 oscillations. That is equal to 0.67. So the frequency F is equal to 0.67 second inverse. Second inverse or hertz you can put. Okay, next B part of the question, we have to find time period. What is the relation between time period and frequency? We have time period is equal to 1 by frequency, or frequency is equal to 1 by time period. Okay, here frequency is 0.67, 1 by 0.67 you will get, or you can just take this. Here we have frequency is 40 by 60. Okay, so this is equal to 1 by 40 by 60, which is equal to, taking reciprocal, 60 by 40 equal to 1.5, and the unit is seconds. So the time period is 1.5 seconds. Understood? So you can find frequency and then find time period, or time period will be equal to, just need to take the reciprocal of this value. Question 2 of exercise 1C. The time period of a simple pendulum is 2 seconds. What is its frequency? What name is given to such a pendulum? Very easy question, right? Here what is given? Time period is given to be equal to 2 seconds. When time period is given, we know how to find frequency. What is frequency? Frequency is the reciprocal of time period, 1 by t, 1 by 2 seconds, which is equal to 0.5 seconds inverse. So the frequency is 0.5 second inverse. Okay, we found the frequency. What name is given to such a pendulum? A pendulum whose time period is 2 seconds is called a seconds pendulum. So this pendulum is called seconds pendulum. Okay, question 3 of exercise 1C. A seconds pendulum is taken to a place where acceleration due to gravity falls to 1/4. How is the time period of the pendulum affected? If at all, give reason. What will be its new time period? So here we know that time period T is equal to 2 pi root of L by G. Time period is directly proportional to root of L and time period is inversely proportional to root of G. So here it is given that a seconds pendulum is taken to a place where acceleration due to gravity falls to 1/4, which means the length of the pendulum will remain the same. The pendulum is not changing. Okay, L value will remain the same. So T1 is directly proportional to 1 by root G1 and T2 is directly proportional to 1 by root G2. Why? Because 2 is a constant, pi is a constant and root L is a constant. So time period here, if there is a change in G, only then we can bring a change to time period. So this is a seconds pendulum whose T value will be equal to 2 seconds. Okay. Now what is given? The relation between G2 and G1 is given. Okay. G1 is the initially what was the acceleration due to gravity. Okay. Now what happens? It changes to 1/4 of its initial value, which means G2 will be equal to 1 by 4 times G1. Okay. So here T1 divided by T2 will be equal to 1 by root G1 divided by 1 by root G2. Okay. So here we are using a seconds pendulum, right? For that T1 value will be equal to 2 seconds. We need to find what is T2. New time period T2 we have to find. Okay. So here put the values. Let it be T1 by T2 is equal to 1 by root G1 divided by 1 by root G2. So G2 is equal to 1 by 4 G1. Yes. So this is 1 by G1 divided by 4. So this is 1 by G1 divided by 4. We have to take the root of it. Okay. So T1 by T2 is equal to, taking the reciprocal of this part, you will be getting 1 by root G1 divided by root 4 divided by root G1, which is 2 by root G1 is equal to 1 by root G1, taking reciprocal, root G1 divided by 2. Okay, root G1 gets cancelled. So T1 by T2 is equal to 1 by 2. Then what is T2? T2 will be equal to 2 into T1. T1, here it is a seconds pendulum, therefore T1 value will be equal to 2 seconds. So 2 into 2 seconds, which is equal to 4 seconds. Okay, what happens now? Yes, the time period is becoming double when the acceleration due to gravity becomes 1 by 4. Question 5 of exercise 1C. Compare the time periods of two pendulums of length 1 meter and 9 meter. Compare means you have to take the ratio. So first T1 will be equal to 2 pi root of L1 divided by G. So here we are considering G to be same because it is at the same place. Next T2 is equal to 2 pi root of L2 divided by G. Here L1 is 1 meter and L2 is 9 meter. This is 2 pi root of 1 by G and this is 2 pi root of 9 by G. Comparing, that is taking the ratio, T1 by T2 will be equal to 2 pi root of 1 by g divided by 2 pi root of 9 by g. 2 pi gets cancelled. G is constant, gets cancelled. Then you will be having root of 1 by 9. T1 by T2 is equal to root 1, 1, root 9, 3. So, T1 is to T2 is equal to 1 is to 3. So, on comparing, we understand the time periods. The ratio of the time periods is 1 is to 3. Question 6 of exercise 1C. A pendulum completes 2 oscillations in 5 seconds. So, we know that time period is equal to total time divided by number of oscillation. We need to find the first part of the question. We need to find the time period. How to find time period? Time period is equal to total time divided by number of oscillations, which is equal to, here the total time is 5 seconds divided by number of oscillation 2. 2.5 seconds is the time period. If g is equal to 9.8 meter per second square, find its length. How to find length? T is equal to 2 pi root of L by g. Okay, from this we can write root L by g is equal to T divided by 2 pi and L is equal to g T square by 4 pi square, which is equal to 9.8 into 2.5 square divided by 4 into 3.14 square. So, when you do the calculation, you will be getting, when you calculate this, you will get 1.55 meters. So, the length of the pendulum is 1.55 meters. Question 7 of exercise 1C. The time period of 2 simple pendulums at a place are in the ratio 2 is to 1. What will be the ratio of their lengths? At the same place means acceleration due to gravity is same. So, time period T is equal to 2 pi root of L by g. Time period is proportional to root L. Okay, T1 proportional to root L1, T2 proportional to root L2. T1 by T2 is equal to root of L1 divided by L2. Here in the question, what is given? Simple pendulum at a place R in the ratio 2 is to 1. The time period ratio is given. T1 by T2 is given to be equal to 2 is to 1, which means 2 by 1 is equal to root of L1 divided by L2. Then how to find what is L1 by L2? To get L1 by L2, we are squaring on both sides. That is 2 by 1 whole square, which is equal to 4 by 1. Therefore, L1 is to L2 is equal to 4 is to 1. So, ratio of lengths is equal to 4 is to 1. Question number 8 of exercise 1C. It takes 0.2 seconds for a pendulum bob to move from mean position to one end. What is the time period of a pendulum? What is time period? So, here you have a support. This is your bob. Okay. It starts moving from here. It will go to its extreme position. Then come back from here. Go to the other extreme position. And come back to its mean position. This is a complete oscillation. Time period is the time taken for one complete oscillation. Here, either it should be like this or it starts from one extreme, go to the other extreme, come back to this extreme. Okay. So, these two are the two cases. Now, here it is given that it takes 0.2 seconds for a pendulum bob to move from mean position to one end. This is mean position to one end. For this journey, it is taking 0.2 seconds. Okay. To come back from here to here, it will take again 0.2 seconds. From here, to move it takes 0.2 seconds. From here to here, again 0.2 seconds. Which means the time period will be equal to time period for one complete oscillation. The time taken is time period will be equal to, this completes an oscillation, 0.2 plus 0.2 plus 0.2 plus 0.2, which means 4 into 0.2 seconds equal to 0.8 seconds. Okay, for one complete oscillation, it takes 0.8 seconds. Question number 9 of exercise 1C. How much time does the bob of a seconds pendulum take to move from one extreme of its oscillation to the other extreme? For a seconds pendulum, we know that time period T is equal to 2 seconds. So, starting from one extreme to move to other extreme. We need to find what is the time taken. So here you can see that this is not a complete oscillation. This is half oscillation. This is half oscillation. We know that time period is equal to time taken divided by number of oscillations. Okay, here we have to find the time taken. Time taken will be equal to time period into number of oscillations. Okay, what is the time period? For a seconds pendulum, time period is 2 seconds. 2 seconds into number of oscillation, half. So you will be getting 1 second. So the time taken for the bob to move from one extreme position to the other extreme position, just a half oscillation, is equal to 1 second. That's all for today. In today's class, we have discussed about the measurement of time and simple pendulum. We have studied how to measure the time period when the length of pendulum and acceleration due to gravity is known. We have studied the expression for time period. We have studied how to plot a graph between t square and L. We have also discussed about seconds pendulum. Hope you have enjoyed this session. We have also solved many questions from exercise 1C. There are a few more questions left which you can solve on your own. I'll be back in the next session with a new chapter. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.